Hello and welcome back. Today we're going to be looking at binomial theorem questions. Now these are specific questions that almost definitely will come up in the exam, so let's get down straight to them. Number 1. Write down and simplify the general term in the binomial expansion of 3 over x minus 2x all to the power of 13. And then the second part of the question is hence or otherwise find the term in x to the power of 9. So, what I like to do on this type of question is bring all of the x's up using our laws of indices. That becomes 3x to the negative 1 minus 2x. That's a appalling x minus 2x. All to the power of 13, right? And so it's asking for the general term up here. General term is important. We don't need the sigma, we don't need to expand the bracket out because we'll be there for a while even doing binomial expansion. So we use the general term, so we don't need the sigma, but we do need the binomial coefficient. So that becomes 13r times by 3x to the negative 1 of 13 minus r times by negative 2x to the power of r. Now that becomes 13r times by 3, we bring that over here to the powers, 13 minus r times by x, negative 13 plus r times by negative 2, bring that here, negative 2 to the power of r times by x to the power of r. Pardon me. That becomes 13r times by 3 to the power of 13 minus r times by negative 2. We're just going to bring the numbers together. Times by, now what we can do here is bring the x's actually together as 1. So this is using our laws of indices we learned from National 5. So negative 13 plus r plus another r gives, well, you've guessed it, negative 13, whoop, that's in green, times by x, negative 13 plus 2r, right? And that's the general term, but if we look at the question, it's asking hence or otherwise find the term in x to the power of 9. So we haven't done the full question yet, we've only done part of it. So we'll rub out all of our working here to save, well, to give some space. So, we want x to the power of 9. What we've got down here is x to the power of negative 13 plus 2r. So, up here, we can make negative 13 plus 2r equal to 9. That's simple, and if we rearrange that, we get 2r equals 22, and then r equals 11. Right? So we've got r now. All we need to do is replace it in all of this and get our coefficient x to the power of 9. Not too hard. So that becomes 11 times by 3 to the power of 13 minus 11 times by negative 2 to the power of 11 times by x to the power of 9, because we've already figured it out. So 1311, if you'll remember, it's not just 13 factorial over 11 factorial times by 13 minus 11 factorial, just to give you a wee sneak revision there of the, what do you call it, factorials. Not just to give you a quick revision of that, but also you can write in your calculator as 13C11. But since we have a non-calculator paper this year, we might have to figure that out. So I've shown you, sorry, I've got the hiccups now. So I've shown you how to do that. So 1311, I'll just do it on the calculator for time's sake. 13C11, 78. 78 times by 3 squared times by negative 2 to the power of 11 times by x to the power of 9. I'll do that all on the calculator. So 78 times by 3 squared times by negative 2 to the power of 11. That's a big number. That all equals, yep, negative 1437696, x to the power of 9. There we go. That's our answer for the first question. A lot of work, but it's worth it. Get quite a few marks out of that, actually. Now, on to the second question. 2a. Write down and simplify the general term in the binomial expansion of 2x squared minus d over x cubed to the power of 7, all to the power of 7, where d is a constant. So, the first part is just the same as the last time. We use the general term. And as I said before, I like to bring all of the x's up. Dx to the negative 3 to the power of 7. So that becomes 7r times by 2x squared to the power of 7 minus r times by negative dx, that x is to the negative 3, to the power of r, which gives 7r times by 2 to the 7 minus r times by x to the power of 14 minus 2r times by negative d to the power of r times by x to the power of negative 3r. Right, so we can bring the x's together just like last time. So 7r times by 2 7 minus r times by negative d to the power of r, because we want the constants to just be together for neatness, times by, so x to the power of 14 minus 2r, so 14 minus 2r plus negative 3r gives 14, x to the 14 minus 5r. That's our general term. So we've figured out the first part. Give ourselves a little round of applause. There we go. But we go on to B now. Or not to be. That is the question. Sorry. Pardon my awful puns. Got a classic humour. So, on to B now. Given that the coefficient of 1 over x is negative 70,000, find the value of d. So, that's handy to know. So, we use our general term again, but we use it as negative 70,000. Okay. Negative 70,000 equals 7... Well, before we do that, actually, I'll rub that out. 1 over x, that means that it's x to the power of negative 1, okay? Right, so x to the power of negative 1, that means that down here, 14 minus 5r has to equal negative 1. You can write that as a simple equation. 14 minus 5r equals negative 1. So take away 14, negative 5r equals negative 15. Wow, that's worked out surprisingly well. Divide by negative 5, that gives r equals 3. And that is correct. So, now we know what r is, we can just replace it in the binomial the general term. So that gives negative 70,000 equals 3 times by 2 to the 7 minus 3 times by negative d to the power of 3 times by x to the power of negative 1. So 7c3, that's just the same as 7c3. I'll do that on the calculator now. 7c3 is 35. Negative 70,000 equals 35 times by 2 to the power of 7654 to the power of 4 times by negative d cubed x to the negative 1. So 35 times by 2 to the 4, 560. Equals 560 times by negative d cubed x to the negative 1. So divide negative 70,000 by 560. This isn't too hard. This is just a tiny bit more than basic equations. So negative 70,000 divided by answer. Oh no, that's not correct. Negative 70,000, 123, divided by 560 equals negative 125 equals negative d cubed x to the negative 1. Now we could have put an x to the negative 1 on the left hand side. It really doesn't matter, I think, for the marking scheme, but if you wanted, you could put the x to the negative 1. I'll do that just for clarity. X to the negative 1. Now all we need to do is cubic root that negative 125. So shift cubic root answer. That gives negative 5. So negative 5 equals the cubic root of negative d. So negative d equals negative 5. So d has to equal 5. And there we go. We have our answer for the second question. We found our value of d. So, thank you very much for watching today. I haven't written an outro colouring book thank you note, so I'll just do it now. So I'm going to, might as well, give you a short talk about the site I use for my revision, and that is freeadvancedhighermaths.co.uk. It's got plenty of questions about binomial theorem, any topic in advanced higher maths for that matter, really. Also, if you're wanting to look back at higher, it has higher questions, and guess what? It also has National 5 questions. How coincidental, eh? Just putting in random colours now. I've always liked mixing colours. It brings you back to the good old days of nursery smelling that paint, doesn't it? Anyway, thank you so much for watching today. I hope you learned something. I hope I'm helping with your revision.